1,200 years ago, in silent halls lit by oil lamps, the first ideas that would one day become AI were already forming. Long before computers existed, ancient scholars were designing systems to make numbers think for them. They didn't call it artificial intelligence, but that's exactly what they were building without knowing it. Our story begins in the ancient world, where knowledge was more valuable than gold. Empires rose and fell, but the quest to understand logic never stopped. Hidden in old manuscripts, the seeds of machine intelligence were planted centuries before electricity. The journey starts with a simple question. How do you make a problem solve itself? This question haunted ancient mathematicians who wanted answers faster than the human mind could provide. They built tools, patterns, and rules, the earliest versions of what we now call algorithms. The word algorithm itself comes from a man who lived over 1,000 years ago. His name was Muhammad ibn Musa al-Khwarizmi, a scholar whose work quietly shaped the entire modern world. He didn't create AI, but he created the structure AI would later stand on. Al-Khwarizmi invented step-by-step logic to solve problems automatically. These steps didn't require emotion, opinion, or guesswork, only instructions. And that's the foundation of every AI model we use today. Imagine writing rules so perfect that even a person with no skills could solve complex equations. That was the power of a system. Intelligence turned into instructions. It was the first time knowledge behaved like a machine. While he worked in the House of Wisdom in Baghdad, other civilizations built their own thinking tools. In China, the abacus was becoming a mechanical extension of the human brain. Every bead moved with purpose, storing memory just like a computer. Greek philosophers explored logic with iron precision. They treated reasoning like a blueprint that could be repeated by anyone. This mindset, repeatable logic, is the heartbeat of AI. Meanwhile, Indian mathematicians invented zero, a symbol that allowed complexity to explode. Without zero, no modern computer could exist. Without zero, AI would be impossible. All across ancient civilizations, the same question was being asked differently. How do we make thinking faster, cleaner, and more reliable? They were building tools, not to replace the mind, but to extend it. These systems didn't feel emotional. They didn't get tired or confused. They just followed rules, exactly like machines do today. So while people think AI began in a lab surrounded by wires, the truth is far older, deeper, and more human. It began with people who wanted clarity in a chaotic world. Fast forward to the 1600s, where European mathematicians revived ancient knowledge. They refined logical patterns like clockmakers' tuning gears. These were the early bodies of machines that hadn't been born yet. Then came the 1800s, and an unexpected turning point. Ada Lovelace, a visionary woman ahead of her time, wrote the first algorithm meant for a machine. She realized something shocking. Machines could follow logic like humans. She didn't just see numbers. She saw imagination hidden inside mathematics. Ada believed machines could create patterns beyond human limits. That idea would later become the soul of artificial intelligence. Meanwhile, mechanical inventors across Europe were building devices that could remember. Punch cards acted like early storage drives. They held instructions just like computer memory. The dream of automatic thinking was no longer fantasy. It was taking shape, piece by piece, quietly evolving. But humanity wasn't ready to call it intelligence yet. Then came the 20th century, the birth era of computers. Engineers finally had the electricity and hardware needed to animate ancient algorithms. Machines could now follow logic without human interference. But true AI required something deeper. The ability to learn. The idea of learning without being told shook the scientific world. Suddenly, intelligence wasn't just rules, it was growth. Enter Alan Turing, the mind who asked the impossible. He wondered if a machine could ever think the way humans do. His question became the foundation of AI theory. Turing created a test to challenge machine intelligence. If a human couldn't tell if the answer came from a person or a machine, then the machine was intelligent. This test still haunts AI researchers today. Every new model is secretly competing to pass its challenge, and most people don't even know Italiano. After World War II, the race to build intelligent machines intensified. The world wanted faster decisions, sharper calculations, and smarter systems. Computers became the new battlefield of ideas. In the 1950s, scientists held the first official conference on artificial intelligence. They believed machines would soon learn, plan, speak, and understand. They were right, but decades early AI struggled because computers were too weak. The ideas were brilliant, but the hardware was slow. Intelligence needed speed, and speed hadn't arrived yet. But humans don't stop when they believe in something powerful. Researchers kept pushing, refining, and reinventing. Every failure brought AI one step closer to success. Then came the Internet, the fuel AI had been waiting for. Suddenly, machines had access to oceans of data. Data became the new electricity of intelligence. AI systems began recognizing patterns faster than humans. They learned languages, identified images, and predicted outcomes. Something that started 1,200 years ago was finally awakening. But the biggest leap came when scientists copied the structure of the human brain. They built neural networks, digital systems, inspired by our neurons. Machines could now learn the way children learn, through repetition. Each layer of the network processed information like tiny thinking units. Each unit improved itself based on mistakes. Intelligence was no longer programmed. It was growing. As processing power increased, AI became unstoppable. It doubly wrote text, solved equations, and made decisions. The ancient dream of automatic thinking was now reality. But even now, AI isn't something brand new. It's the final chapter of a story that started centuries ago. A story written by scholars who never imagined the impact of their ideas. The truth is, AI is not a modern invention. It's the evolution of human curiosity. Every generation added one brick to a tower of intelligence. The abacus was the first memory unit. Algorithms were the first instructions. Philosophy was the first logic model. AI today is simply the most advanced version of these ancient tools. It carries the fingerprints of mathematicians, philosophers, and inventors. Their knowledge flows through every line of code. So when someone says AI is dangerous or mysterious, they're misunderstanding what it truly is. AI is human knowledge, automated. It's the same logic, the same curiosity, the same desire for understanding, only faster, sharper, and more powerful. And it all started with civilizations that wanted better answers. When you use AI today, you're touching the work of thousands of forgotten minds. People who lived long before electricity, computers, or smartphones. They laid the foundation for the intelligence we now take for granted. The journey of AI is the journey of humanity, a story of learning, improving, and evolving. A story that began with ink on parchment and ends with machines that learn on their own. And now, we stand at the edge of a new chapter. Ancient logic has merged with modern technology. Human intelligence and machine intelligence are finally walking the same path.